Welcome to The Explainer. Today, we're diving into something really out there. We're looking at a fascinating analogy from our source material that tries to build a conceptual bridge, a kind of Rosetta Stone, between the super abstract world of pure mathematics and a speculative theory of everything. So let's get right into it. The big question is this: what if the language of math isn't just for describing planets and particles? What if it could actually create a map for a theory of everything that includes not just physics, but the very emergence of life, and maybe even our sense of ethics? So you've got these two totally different worlds, right? On one side, you have the Langlands program, this deep, respected, but seriously complex web of ideas in pure math. On the other side, you have this wild, speculative idea called 81D Kanamori math, which basically says that everything, you, me, the stars, all comes from a fundamental set of rules, like a cosmic syntax. The goal here is to see how someone tried to build a bridge between the two. All right, here's our game plan for today. We're going to start with the big picture, then connect the main ideas, see how they build this powerful new tool, and then, at the end, ask the big question: why does any of this even matter? Okay, first things first. We need a blueprint. Before we get lost in the details, the source material lays out a direct top-down map, lining up the absolute core principles of both of these worlds. So check this out. The Langlands program is built on this beautiful idea called dual description. Basically, that two very different mathematical viewpoints are just two sides of the same coin. Well, that gets mapped directly onto Kanamori math's core idea that existence is creation, or E=C. That's another kind of duality, saying that an object and the rules that create it are, fundamentally the same thing. Okay, so with that big picture map in place, we can get to the fun part. We can start building a sort of dictionary, connecting the specific things that live in each world one by one. It's like we're translating from the language of number theory into the language of this weird syntax universe. The analogy kicks off with the most basic object you can think of. In the math world, that's something called an elliptic curve. In the Kanamori universe, it's a 1D syntax life form. The connection here is that they're both seen as the simplest possible self-contained system that has its own rich set of internal rules. And that leads to this really cool parallel. In math, something called a Galois group describes all the hidden symmetries of an equation, like the unspoken rules of the game. Well, in this analogy, that's mirrored by a syntax symmetry group, which is supposed to be the set of deep, unchangeable laws of the Kanamori cosmos itself. And finally, you've got these things called automorphic forms. Now, they're super complex, wave-like functions in math, but the analogy here maps them to breathing tensors. You can just think of these as the fundamental rhythm or the pulse of a structure in this Kanamori universe, almost like its heartbeat. So right about now, you're probably thinking, okay, this all sounds nice, but is it just a bunch of pretty words? Well, here's where it gets really compelling. The answer lies in this powerful tool that both worlds can supposedly use to create a unique fingerprint for their objects. In math, that tool is the L function. And honestly, the best way to think about it is like a spectral fingerprint. It takes all the crucial data about a mathematical object and encodes it into a single function. It's a lot like how a prism takes a beam of white light and breaks it down into a rainbow of colors. The properties of that rainbow tell you hidden truths about the original light. Whoa, okay, don't panic when you see this formula. You absolutely do not need to know what every symbol means. Here's the key idea. It's an infinite product that goes through all the prime numbers. It systematically grabs a little piece of information from every single prime and then bundles it all together into one beautiful function that acts as that unique fingerprint. All right, now for the part that sounds like it's straight out of science fiction. The source material says, hey, what if we built our own L function? But instead of using prime numbers as the building blocks, this fingerprint is supposedly built from the universe's own physical and informational properties. So how do you actually do that? Well, the process is designed to perfectly mirror what mathematicians do. Step 1, you measure local stuff. But here, that means things like information compression, a type of complexity called Soul entropy, and even a so-called value function. Step 2, you mash those three things together into a single number. And step 3, you assemble all those numbers into an infinite product, just like the mathematicians do with primes. And this little term here, this WP of t, is the absolute heart of the entire analogy. This is the translation key. It takes these really out-there concepts from Kanamori math, information, entropy, value, and it boils them all down into a single number that you can just plug right into that elegant mathematical machine, the L function. And boom, here's the final result. Just look at it. The structure of this function is identical to the one from pure math we saw a second ago, but its DNA, its guts, that WP of T term, is built from a completely different universe of ideas. This function, right here, is the keystone that locks the whole crazy bridge together. So, we've built the bridge. It seems to hold up. But we have to ask the most important question of all. So what? What's the point? Why go through all this trouble to connect real, established math with this incredibly speculative physics? Well, our source suggests some pretty fascinating uses. For starters, it could give a very speculative theory a real, rigorous mathematical backbone. It could also create totally new analytical tools. I mean, can you imagine using the power of L functions to study something like information flowing around a black hole? And the idea is actually concrete enough that you could even try to prototype it in code, building a tool to explore these connections visually. You know, in the end, this whole thing isn't just about math or some wild theory of everything. It's really a powerful example of how analogy, just thinking, what if this is like that, can be a real tool for discovery, for building bridges into the unknown. And it leaves us with one final thought. If a map like this is even possible, what other incredible, hidden connections between worlds of ideas are just waiting for someone to draw them?